Hello students, this is Mr. Merivak. As you can see, I am not there in the classroom. So I thought that I would record this lesson and you guys can watch it without me. On Friday, we talked about finite differences and we determined that if you know the degree of the function, you can predict which finite difference is going to be constant. So what I mean by that is if I have equations such as y equals x to the power of 5, I know that fifth finite difference is going to be constant. There is also a shortcut where we can actually calculate what the value of that finite difference is. And this is the formula that we're going to use. So in this example um, that I just had, let's say y equals x to the power of 5, I can use the information from that equation and apply it in this formula here, and I can calculate what the value of the fifth finite difference is. Before we begin that, we should clarify what this formula, what it actually represents. There is a symbol, a, n, and there's this exclamation mark. This part actually represents a factorial, and factorial is just another way of expressing a mathematical calculation that is very large. And in this case, factorial represents, well, I guess it's better to show you. So for example, if I have a 6 factorial, how I calculate and expand that factorial is that I multiply every number in a decreasing order all the way down 1. So in this case, nope, that is not the right answer. 6 factorial would be equal to 720. If we had a smaller number, like 3 factorial is the same thing. We are multiplying consecutively decreasing numbers all the way down. So in this case, it's just going to be equal to 6. And we are just going to use that in the formula to calculate what the value of the finite difference is. So I'm going to start, actually here's another example, y equals 3x to the power of 6. I could create a table of values, do the first difference, second difference, all the way down to sixth finite difference, and I can actually determine what the value is, or I can use the formula, and this is how I would draw it, delta y for sixth difference is equal to a n factorial. In this case, a is our leading coefficient, which in our equation is 3 times n is our degree of the polynomial. So I guess we can connect it like that. And this one is this. If I substitute factorial and expand the factorial, 6 times 5 times 1, we can calculate what the value of our finite difference is. And it seems like it is 2,106. So this is just a fast way to find out what the value of the finite difference is without doing all that work that we were doing earlier on Friday. Another type of question that we were going to encounter is something like this on the next page. And in this question, it says that we need to determine the degree, the sign of the leading coefficient, and the value of the leading coefficient. We only have the table of values with x and y values entered. So unfortunately, we do have to do some first, second, third, fourth differences and determine what kind of polynomial this is. If our first differences are the same, then it's going to be easy. We know that it's a linear function and we can go from there. So I have a few values here that I can enter. So the first difference is 46, 8, 6, 16, 14, negative 24, and negative 122. There we go. Obviously, we can see that these are not constant, so this is definitely not a linear function, and we proceed to calculate the second differences. In this case, it's negative 38, negative 2, 10, negative 2, negative 38, and negative 98. Again, not constant, so we have to keep going. Negative 36, 12, negative 12, 36, and negative 60. So it is not a cubic function either, so hopefully our fourth differences are going to be constant, and they are all the way down. This gives you two pieces of information. It tells us that it is a fourth degree polynomial, so I can put down here the fourth degree polynomial. Because the finite differences are negative, negative 24, I know that the sign of the leading coefficient is also going to be minus. And we still have to calculate the value. So for value, we're going to go to our formula, delta y for the fourth differences. It is still a n factorial. We have delta y for the four differences. We have the fourth difference value, which is negative 24. We are looking for the value of our leading coefficient, which is n. And the other part that we have is that this is degree 4 polynomial, so n is 4 factorial. We can simply isolate a as our variable, which is 4 over 4 factorial. And if you expand the factorial, you will get that it is negative 24 over 24, which gives us the value of leading coefficient of negative 1. So we can enter that here in this little summary table. And that is it. These are just a few examples where this formula might be used and how we can connect the degree of the polynomial and the finite differences. Here are a few practice questions that you can work on from the textbook and the workbook, and I will be back tomorrow to answer any questions that you might have. Bye.